Okay, it's time. We're going to talk about imaginary numbers and I. So far I've told you it's not possible to take the square root of a negative number. That is still true, you can't. But in math, for some reason, people came up with a way to handle this. It's called I, and the concept of imaginary numbers. So imaginary numbers are all square roots of negative numbers. So this is an imaginary number, this is an imaginary number. Any square root of a negative number is imaginary. So the way we get around this is by rewriting it as a product of -1. So what I'm saying here is that we take whatever number is inside the square root and we rewrite it to look like this. The square root of -1 times 4. So now because of the product property of radicals, which I tortured you with before, we can split this into two pieces. The square root of -1 times the square root of 4. And now our life becomes a lot easier. While this product is still imaginary, we can rewrite it as, okay, we're going to say the positive square root of 4, which is 2, and there's a special name for the square root of -1. Another way of writing the square root of -1 is I. So I is meant to represent the square root of -1. So what we can do then is say, okay, instead of saying the square root of -1, we write I. And when we rewrite this product, it simply becomes 2i. The same thing goes for any number. The first thing we do is simply convert it to be the square root of -1 times positive 16. Then we split it into two pieces, the square root of -1 times the square root of 16. And then we simply kind of do our little cross thing here, and we get 4 times I, 4i. And we consider this fully simplified. I will never be a real number. I is always an unreal number. It's always imaginary. We can't do anything with it. So when we see something like this, 5i plus 7i, there's literally nothing else we can do with it besides treat it like it's an unknown variable, like x. And so we can simply combine it and say 5i plus 7i becomes 12i. And it acts just like x would or any other letter variable. Okay, so we already know that I is the same thing as the square root of -1. However, I has some very interesting properties. If I have I squared, which is now the square root of -1 times the square root of -1, that becomes -1. It's no longer an unreal number, it is no longer an imaginary number, now it's just, so in that way, if I have I to the third power, we know that becomes I squared times I. If we know that I squared can be replaced with -1, then we can simply write that as -1 times I, or -I. Lastly, if we have I to the fourth power, we get I squared times I squared, which is -1 times -1, which becomes +1. So you see this cycle. I is imaginary, I squared is not imaginary, I cubed is imaginary, and I fourth is not. So you see that every time I has an even exponent, it becomes a real number. So this allows us to have some certain shortcuts. What happens if we want to simplify I to the 67th power? Well, instead of saying, okay, that's I squared times I squared, how many I squareds are there? We don't want to do that. So the easiest way to do this is to take the exponent and divide it by 4. We'll see that we get a remainder of 3. So we technically have I to the fourth 16 times, and then we also have I to the 3. Well, we can remember that I to the fourth can simply be replaced by +1, which means that we have 1 to the 16th power times I to the third. Well, weirdly enough, 1 times whatever just makes it stay the same, so we have I to the third, which is functionally the exact same thing as I to the 67th. It just goes in cycles of 4 over and over again. So this remainder tells us what the exponent will be on that final product. We'll do one more example and then I'll show you the final use of I, where we're actually going with this. If I wanted to simplify -3i to the third, what I could do is remember that if I look at my little chart of the I cycle, which I hope you wrote down in your notes, then you have -3 times I squared times I. We didn't make it to 4, so we have to stick with 2. We know that the definition of I squared is -1, and we can't do anything with I, so it stays here. So -3 times -1 is +3, and then we simply get a result of 3i. Now, what has been the point of me telling you all this random stuff about I? Well, this comes in handy when we have the quadratic equation. What if we're trying to solve something like negative 4x squared plus 8x minus 5. Let's say you're like, well, obviously the factoring method doesn't work on this, and SADMAP won't work on it either. My only recourse is to go with quadratic equation. So I go x is equal to negative b. So in this case I've gotten 1 plus or minus the square root of negative 16 over negative 8. Well, now that we know about I and imaginary numbers, we can actually go ahead and make that a little bit more simplified. I'm going to convert this top part into a product of I. So over here I'm thinking, okay, so this is the same thing as square root of negative 1 times the square root of positive 16. So when I rewrite that, I can say 1 plus or minus 4i all over negative 8. Interestingly enough, now we can actually simplify 4 and negative 8, which have common factors, and we get 1 plus or minus I over negative 2, which is kind of awkward because of this negative 2 on the bottom. I'm simply going to rewrite it as 1 minus or plus I over 2. I mean, which is technically the same thing as plus or minus, so this basically here stops mattering. And if I'm perfectly honest with you, I have no idea why we do this, and I have no idea why we wonder about imaginary solutions. I really don't. What you do know about this is that it never crosses the x-axis, so now you found an answer that doesn't tell you anything? Probably it does. Who knows?